Hi, this is Angel Zelazny, and I'm recording my presentation for English 516 over my literature review topic of visual stylometry. To begin, I want to give you a background on where visual stylometry comes from. So first, we have to see that visual stylometry falls under the umbrella term of digital image processing, which is essentially the process of taking images and analyzing them using computer algorithms. Now, the term stylometry has been around since roughly 1894, but it's always been defined in the context of literature. For example, looking at style deviations between writers or genres of literature. However, as of late, we've seen that the field of visual stylometry has started to take off, and there are two reasons for this. First, we have to look at the proliferation of data about artwork. As of late, we've seen that the number of high-resolution images that anybody can have access to has skyrocketed. And when you have data, that means there's someone out there who wants to analyze it, which means we also have to evaluate the machine learning aspect of visual stylometry. In recent years, machine learning advancements have also vastly improved. And in conjunction with the fact that we have way more data about artwork out there, this means visual stylometry is more important now than ever. So all in all, we can see that visual stylometry is essentially just looking at artwork and trying to define its style. There are multiple things that you can analyze under this field, such as who the author of a painting is, or what sort of colors it uses, and how you can trace that back to its time period or what sort of materials it's using. Essentially anything you can think of about art, you can analyze with visual stylometry. Now, we can also take a look at these two images here, which are from the Metropolitan Museum of Art's public data set. So from these images, we can see that what's defined as art is also widely varying. So when looking at this literature review on visual stylometry, there's a few major questions that we want to ask ourselves. One of those is, what has been the most successful methods of visual stylometry? If we ever want to do future research, we should know what some of the most successful methods have been. Another question is, how is visual stylometry currently limited? When looking at current research, we see almost all of it is in regards to painting. However, as we just showed on the previous slide, there are a lot of different mediums of art. So when looking to the future, we want to think, what sort of different kinds of art can we be analyzing, and how can we improve our techniques? And finally, we also want to ask the major question of, how can this change the way we think about art quantitatively? Usually when people think of art, they just think of qualitative aspects, but it can be really useful to try and quantify art to be able to better analyze it and group it, and in general make the job of art experts a lot easier. So moving on, I want to paint a picture for you of what exactly visual stylometry is. And I'll do this using a case study. Specifically, we'll look at a paper published by Key, Tabe, and Hughes of how they attempted to train an algorithm to identify authentic works of Van Gogh versus non-authentic works of Van Gogh. So there's definitely a process when looking at visual stylometry. One of the first things you want to do is identify your objective. Now, the objective of this case study is to see if a computer can tell real Van Goghs from fake Van Goghs. Now, how you train your algorithm and what data sets you use are going to differ a lot based on what your objective is. For example, if you just want to analyze all the different colors in a piece of art and see if you can tell different pieces of art and categorize them into time periods based solely off the brightness of their colors, then that's going to change your data set. Second, you need to break the art down. If, for example, you were looking at different uses of color in art, you would break up the image into different sections of color and how they use it. In this specific case study, since we're looking at Van Goghs, what these authors end up doing is looking at only the background of the paintings, since they consulted with a psychologist on this and decided that the background of a painting is more of a subconscious action, whereas the foreground is meticulously painted, so it'll be harder to tell who the actual author is if we only look at the foreground, because the background will be more indicative of who painted it. And finally, in the process of visual stylometry, you're going to want to test your model. The researchers in this case study tested their model by putting fake pieces of Van Gogh art into the model and seeing if it could correctly classify them as real Van Goghs or fake Van Goghs. So moving on from this, here are a few examples of some of the images that these researchers used to train their algorithm. These are just a few images in their data set. And you can also see that they broke it up between periods. They have the Arliss period and the Paris period. And the researchers were able to use this to also see if the computer algorithm they trained correctly identified not only if it was a real Van Gogh painting, but what period it came from as well. And down in the bottom, you can see that here are some paintings that are commonly mistaken as Van Goghs or have the same artistic style. And this is what they used to test their model to see if it could correctly classify the paintings. So moving on, we can look at these two images here and see that in both of these images, the background is denoted with a small white dot in the corner. So, as we discussed earlier, these researchers decided it was really important to differentiate the background from the foreground of the painting, because it's harder to tell who the artist is based off the foreground, since they don't really subconsciously paint the foreground. They spend a lot of careful time painting it. Whereas the background is something that's more just automatic. They just do it without really thinking. And that's more indicative of who the author of the painting could potentially be. This is another example of how interdisciplinary visual stylometry can be. This might not have been something that a statistician thought of on their own without the help of maybe an art expert or an art connoisseur who could help them guide them in how to train their model based off of common art techniques. So next, we want to look at how these researchers quantified the art. So one of the questions we asked was, how do you quantify something as inherently qualitative and subjective as art is? And one of the most common techniques used in visual stylometry is that of the hidden Markov model. This is by far the most popular in all of the scholarly articles I've read, but there are, of course, other techniques such as the sparse coding model. However, for now, we want to focus on the hidden Markov model. Essentially, what the hidden Markov model does is it models a system in which there are a sequence of events with hidden states. Now, this sentence is probably pretty confusing, but we can break it down by looking at a simpler example. For example, we can look at a common statistical problem known as the ball and urn problem. In this, somebody chooses balls out of an urn. So if we want to apply that to hidden Markov models, think of one person in a room full of urns. You don't know how many urns there are, and you don't necessarily know how many balls are in each urn. The person in the room randomly chooses a ball from any urn, and then it's handed to another person. However, the second person doesn't know which urn it came from. All they are seeing are these sequences of balls being pulled. They're able to look at what the ball is labeled as, but not which urn it came from. And this would be considered a hidden state. So after the researchers decide to use this model, essentially what it does is extract wavelets from the painting. And wavelets is kind of just a fancy term for a mathematical representation of a brush stroke. So going back to our case study of telling fake Van Goghs and real Van Goghs apart, we can see that our researchers used hidden Markov models along with their hypothesis that the background of a painting would be more useful than the foreground of a painting to analyze how their algorithm did. And we can see from the results in the top table that more often than not, their uh, their models were usually better than previously used models. And we can see that in this first column, their methods got 92.59% of real Van Goghs correct. And it got 63.64% of non-Van Goghs correct. So the overall percentage correct was 87.69%. So it's obviously not 100% perfect yet, but it can definitely be an aid when art connoisseurs are trying to identify the author of a painting but are struggling. Having something like this can help validate their decisions and ideas. Now, looking to the bottom graphs here, we can see that the red circles indicate a real Van Gogh and the blue triangles indicate a non-Van Gogh. And what this graph is showing us is the distance between the real Van Goghs and the non-Van Goghs. The further apart these 2 points are, we see that this means the algorithm was able to tell this non-Van Gogh did not have a similar brush stroke style to the real Van Gogh. So the further apart these points between the red circles and blue triangles are, the better for the model. So finally, we're going to want to look at some conclusions, which is that visual stylometry requires a really interdisciplinary approach because both humanities experts and technical experts will really have to collaborate in order to create even more accurate models. Next, we can also look at improving techniques because we know in the future machine learning and digital image processing is just going to improve, which means our methods of visual stylometry will also improve, which means we might start looking towards different mediums of art other than just paintings. And finally, we can look to broadening our horizons. The techniques used in visual stylometry aren't limited to just paintings. There are so many other technological trends that we could apply them to, such as natural language processing or looking at images of cancerous growths and determining whether they're malignant or non-malignant. So overall, after this brief overview of visual stylometry, here are a few references that were used in these slides if you want to do further reading. Thank you for your time.